Hello everyone, I am obviously not here today, so you get to enjoy me on video. So, we're going to continue on with some new power rules today. We have two new ones to learn today, but all the while today, no matter what we do, all throughout this chapter, we still have to keep in mind all the exponent rules that we've already learned. So we know anything to the 0 power equals 1. We know if you have a negative exponent, to make it positive, flip the power over the fraction bar. And yesterday we learned that if you multiply powers that have the same base, you add their exponents. So what yesterday looked like a cubed times a to the 5th. Okay, and my rule said we add the exponent, so it should be a to the 8th. But the reason why it's a to the 8th, if we think about what a cubed means, it means a times a times a. A to the 5th means a times a times a times a times a. And if I were to write all of those out, there would be 8 a's being multiplied together. So that was yesterday's rule. Okay, so today's rule, two different rules. The first one is a power of a power. And this one and the one we learned yesterday are the two that are most commonly mixed around and confused. We want to try really hard to keep these separate, which is why it's really important that we understand why the rule works just as much as remembering what the rule is. So what the power of a power looks like, it's going to look like this. A to the m to the n power. So we have a power, a to the m, raised to a power, that's the other exponent there, the n. Okay, now this rule says you can multiply these exponents. So I mentioned this yesterday whenever we were in class, that you have to keep them separate because sometimes you're going to add and sometimes you're going to multiply. Up here, what we did yesterday, this is where you add. This is what we're doing today. This is where we're going to have to multiply. Okay, so now the reason why this works, okay, let's say I have 5 to the 4th squared. Okay, now my rule says to take 5 to the 4th squared, I can multiply my exponents. That's 5 to the 4 times 2 should be 5 to the 8th. Now the reason why we multiply and don't add, if we think about what this actually means, 5 to the 4th squared, what it actually means is 5 to the 4th times 5 to the 4th. Okay? Well, and if you look at this is the rule from yesterday, right? Multiplying powers with the same base. So you would add these exponents, 4 plus 4. Well, guess what? 4 plus 4 is the same thing as 4 times 2, which is why we can just multiply those to give you 5 to the 8th. Okay, the other rule that we have is called the power of a product. So if I have a product such as AB and raise it to the nth power, what the power of a product rule says is this is the same thing as taking a to the nth power times b to the nth power. So instead of raising the power to the nth power, I can take each thing inside there, raise it to the nth power, and it's the same thing. And once again, we want to understand why this works. So if I have 3x to the 4th power. Okay, now my rule says this is the same thing as 3 to the 4th power times x to the 4th power, or if I simplify that out just a little bit, it would be 81x to the 4th. But once again, we want to understand why this works. If I think about what 3x to the 4th power actually means, it means 3x times 3x times 3x times 3x. 3x being multiplied by itself 4 times. Well, guess what? If you look at this, 3 times 3 times 3 times 3, 3 to the 4th. X times x times x times x, x to the 4th. So the big thing with this rule is the big common mistake that people make is they forget about that coefficient in there, okay? Don't forget about the coefficient. You have to raise anything inside the parentheses to whatever power you have up there. Okay, so let's look at some examples here. All right, so first problem we have, let's say I have x cubed times x to the fifth. So it's going to be really important today to keep these rules separate and think about what they mean. This is actually the rule from yesterday. This is multiplying powers that have the same base. X to the third times x to the fifth. They both have the same base. So what the rule yesterday said, I can add these together. We should get x to the eighth. And remember, the reason why we're able to do this is because x cubed is x times x times x. X to the fifth is x times x times x times x times x. So if you have 3 x's and 5 x's, there's 8 x's all together. That's why it's x to the eighth. Okay, number 2. What if I have kind of the same thing, but what if I do x cubed to the fifth power? Now, this is actually the rule from today. This is the power of a power. X cubed to the fifth power. So the rule today says that I'm supposed to multiply these together. And if you remember the reason why we multiply them together, if I think about what x cubed to the fifth power actually means, it's x cubed times x cubed times x cubed times x cubed times x cubed. And then if I apply the rule from yesterday, multiplying powers with the same base, I would add all of these exponents. I would take 3 plus 3 plus 3 plus 3 plus 3. Well, guess what? When you add 3 5 times, isn't that the same thing as 3 times 5? That's why you can multiply. Okay, and then number 3, let's say we have x to the fifth cubed. Okay, well, this is the rule from today, the power of a power. And notice it's almost the same thing as what we just did, isn't it? So we're going to take 5 times 3. We should get x to the 15th. Okay, let's move on. Let's try. Okay, number 4 says y cubed to the negative fourth. This is the rule from today, the power of a power. So we're supposed to multiply these exponents. We get y to the negative 12th. Okay, and think back to what we talked about the last 3 or 4 days. Cannot have that negative exponent. So what I need to do is kick that down to the denominator so it becomes 1 over y to the 12th. Number 5 says a cubed squared times a to the fourth. Now this one is actually going to require both the rule from yesterday and today all in one, because this first power here, this is a power of a power. This is the rule from today where I'm going to multiply these exponents and it should give me a to the sixth. But then when I take a to the sixth times a to the fourth, this is the rule from yesterday where I'm multiplying powers that have the same base. So this is where I add the exponents and I should get a to the 10th. Number 6 says b to the negative fourth squared times b cubed. So almost the same thing as the one we just did. We're going to have to use both rules. So in this first power right here, we're going to multiply. I get b to the negative 8th, and then we'll leave the times b to the 3rd. And then to get to your answer, when multiplying powers with the same base, we add the exponents. I'd get b to the negative 5th. And then just like always, to put it in simplest form, we cannot have any negative exponents, so we would need to move that power down to the denominator to get 1 over b to the 5th. Okay, we've got a lot of examples here today because there's just a lot of different things that can happen. Okay, so let's look at number 7. Number 7 says 6x squared. Okay, now you have to pay really, really close attention. Just like I've been telling you the last few days, the parentheses are very, very important, especially on this one. So since there's parentheses around the 6x, this is telling me that I'm squaring the whole thing. I'm taking 6x squared, not just the x, I'm squaring the 6 as well. This is that second rule from today that says if you take the power of a product, you can take 6 squared and x squared, and it's the same thing. Okay, well 6 squared is 36, x squared we leave as x squared. And remember, the reason why this rule works, 6x squared means 6x times 6x, which is where the 6 squared and the x squared comes from. Number 8 says 5x cubed. Okay, so same thing as we just did. I have the power of a product. The big thing with these ones is don't forget about the coefficient. If that 5 is inside the parentheses, that 5 has to be cubed. So it's going to be 5 cubed, and then I also have to take x cubed cubed. Okay? Well, 5 cubed is 5 times 5 times 5, which is 125. And then when you take x cubed cubed, this is a power of a power. So we multiply the exponents, I'd get x to the 9th. Number 9 says 3x squared to the negative 3rd. Okay, I know I have a negative exponent, but the rule still applies even if the exponent is negative. This is telling me that everything inside those parentheses needs raised to the negative 3rd power. So I have 3 to the negative 3rd. I have x squared to the negative 3rd. Okay, now the first thing that I would probably do right here, since I have the power of a power, we would multiply those exponents and get x to the negative 6th. The next thing I would probably do, I really don't like dealing with negative exponents. So since both of these have negative exponents, I'm going to move both of them down to the denominator. So I have 1 over 3 cubed x to the 6th. And then 3 cubed is 27. So we would say 1 over 27 x to the 6th. Okay, number 10. Number 10 says x cubed y to the 4th squared. Okay, this one's going to require a couple rules. First and foremost, I have the power of a product, which tells me everything in here needs to be squared. So we're going to take x cubed squared. We're going to take y to the 4th squared. And then to simplify each of these, both of these are powers of powers. So we would multiply these exponents and get x to the 6th, y to the 8th. Number 11, negative x cubed y to the 5th cubed times xy squared. Okay, this one can get kind of tricky. So yesterday we focused a lot on this idea of what operation you're being asked to do. Now I do have an exponent, and that's the first thing that we need to address. But aside from that exponent, there's just a bunch of multiplication here. Now this exponent you have to pay close attention to. So I'm supposed to cube everything inside here. The big thing here, that negative sign, it is inside the parentheses, which means that negative sign also has to be cubed. So if you think about what happens whenever you cube a negative times a negative times a negative, well, guess what? It's still negative. So I'm going to have negative, and then when I take x cubed, we are going to multiply those exponents and get x to the 9th. When I take y to the 5th cubed, I would multiply those as well, and I'd get y to the 15th. Okay, now the times xy squared, not really a whole lot I can do with that, so we would leave it the same. And now, notice, this is just 4 things being multiplied together, so I'm looking for the powers that have the same base. X to the 9th times x, we're going to have negative x to the 10th, and then y to the 15th times y squared is going to be y to the 17th. Number 12. Okay, this one says a squared b cubed to the negative 2nd times a to the 4th b. Okay, this first set of parentheses here, everything in here is being raised to the negative 2nd power. So that's the first thing. I have to take a to the 2nd to the negative 2nd power, b cubed to the negative 2nd power. In the process of doing that, we are going to have to take the power of a power, which means in the end, I'm going to be multiplying. So when I take a to the 2nd to the negative 2nd, 2 times negative 2 gives me negative 4. When I take b cubed to the negative 2nd, 3 times negative 2 gives me negative 6. Now in that second set of parentheses, it's just a to the 4th b. That's it. There's no number outside the parentheses there, so it just stays that way. And then just like we did on the last one, we're looking for the powers that have the same base. A to the negative 4th times a to the 4th 4 plus 4 gives me a to the 0, and guess what? Anything to the 0 power is 1, so we won't see that. B to the negative 6th times b gives me b to the negative 5th, which, to make that negative 5 a positive 5, we'll flip it to the denominator. Okay, I only have 3 more. Let's say we have number 13, 5x to the negative 3rd squared times 4x to the negative 2nd. You really have to pay close attention where the exponents are and what the base is for each of those exponents. So for this one, the base for the squared is 5x to the negative 3rd. So all that needs squared. All of that needs raised to the negative 2nd power. So when I take 5 squared, I get 25. X to the negative 3rd squared, you multiply, you get x to the negative 6th. When I take 4 to the negative 2nd power, not something that I can probably do in my head, so I'd probably just keep it as 4 to the negative 2nd power, and then we have x to the negative 2nd power. What I would probably do next, I'm recognizing that I have x to the negative 6th and x squared, so we can do 25 times 4 to the negative 2nd. When I multiply those together, this is where we add the exponents, and I get x to the negative 8th. And then the next thing I would probably do, both of those powers have negative exponents, so we'll leave the 25 in the numerator, the 4 goes to the denominator, the x goes to the denominator, and then the last thing, 4 squared is 16. So my final answer would be 25 over 16x to the 8th. Number 14, say we have negative x cubed y times 3x cubed y squared. Okay, so that first group there, the negative x cubed y, can't really do a whole lot with that, so we'll leave it as negative x cubed y. But the second one, I need to square everything that's in there. 3 squared is 9, x cubed squared is x to the 6th, and then I have y squared. Okay, now we did this yesterday a little bit. There's actually a 1 in front of that negative sign, so when you take negative 1 times 9, my coefficient's going to be negative 9. X cubed times x to the 6th should be x to the 9th. Y times y squared is y cubed. And last one, let's say number 15. Okay, we have negative 3a squared b cubed squared times negative 3ab squared. Once again, you have to pay really close attention where the exponents are, what's included in the parentheses, things like that. When I look at the first group here, everything inside here needs to be squared because everything is inside the parentheses. So whenever I square the 3, I need to square the negative 3. It's going to be negative 3 times negative 3, which gives me 9. A squared squared gives me a to the 4th. B cubed squared gives me b to the 6th. Now that second set of parentheses, there's nothing I can do to simplify it, so we'll leave it as times 3ab squared. And remember, that is a times, not a subtraction sign. So then to finish this one off, 9 times negative 3 gives me negative 27. A to the 4th times a is a to the 5th. B to the 6th times b squared gives me b to the 8th.